Good morning. So guys, what we're going to do today is we're going to go over just kind of introduction to 5-4, which is all about the sum and difference formulas. So what we're going to do, we're going to start with the sum and difference formulas. Since we're in an online setting right now, I'm actually going to kind of copy and paste them in, and we'll talk about how we're going to be using them. So give me one second. Okay, so these right here are what are called the sum and difference formulas. So this whole year, we've been working with different trigonometric identities to manipulate equations so that we can better solve them with and without a calculator. So these right here are the sum and difference formulas. The reason we call them sum and difference is basically I go from a sum on the inside to a sum on the outside. And I also go from, looks like right here, I go from a sum on the inside to a difference on the outside. So it really depends on what the question is. But we can note that I keep the same operation if I have a sign, and it seems like I switch the operation if I have a cosine. So we can kind of just keep that in mind. Let's go ahead and see how can we use these formulas. Sine of A plus B is equal to sine of A cosine of B plus cosine of A sine of B. Let's see how we can use these to our advantage. First one, I want to find the exact value using sum and difference formulas. Okay, cosine of pi over 12 is tricky because I actually don't know cosine of pi over 12. So really what I would like to do, is there a way for me to write pi over 12? Is there a way for me to write pi over 12 as a sum or difference? So go ahead and take a pause and see if you could rewrite pi over 12 as something plus or minus something. Okay, so hopefully after pausing, there are so many answers here. You want to use two angles that are on the unit circle. So the angles I'm going to use pi over 3. I'm going to use pi over 3, and then I'm going to choose to subtract. So pi over 3 minus pi over 4 does equal pi over 12. And let me just make sure we're clear on that. If we review how do we subtract fractions, I need to get a common denominator. If I multiply this one by 3 over 3, and I multiply this one by 4 over 4, I get 4 pi minus 3 pi all over 12, which does equal pi over 12. So I'm going to actually rewrite cosine in terms of a difference, and we're going to apply the sum and difference formula. So we'll say cosine of 3 pi, cosine of pi over 3 minus pi over 4. Now I want to go ahead and apply the sum and difference formulas. I'm going to keep them right next to me for my reference. So the one I want to use is this one right here. I have a difference. All right, so it says cosine of A minus cosine of B is equal to cosine A cosine B plus sine A sine B. So I'm going to interpret pi over 3 as being A, and I will interpret pi over 4 as being B. Let's go ahead and rewrite this. This is going to be cosine of 3 pi over 4. Oh my gosh, I don't know why I keep saying that. Pi over 3 times cosine of pi over 4 plus sine of pi over 3 times cosine of pi over 4. And you can see that we actually don't even need a calculator to evaluate this because we have our unit circle. So our unit circle, I want to know what is the cosine of pi over 3. Cosines, or ordered pair, is 1/2, comma, radical 3 over 2. Sorry, pi over 3's ordered pair. Cosine of pi over 3 is 1/2, so we get 1/2. Cosine of pi over 4 is radical 2 over 2. Plus sine of pi over 3, that's radical 3 over 2. Times cosine of pi over 4 is radical 2 over 2. So if I add both of these together, I get radical 2 over 4 plus radical 3 times radical 2 is radical 6 over 4. So I get radical 2 plus radical 6 over 4. And that right there is actually the solution. All right, let's try another one. So hopefully we're starting to get the hang of this. Next one, we're going to not write in radians anymore. We're going to go ahead and write in degrees. Sine of 75. So sine of 75 degrees, I want to use the sum and difference formulas. I don't have 75 degrees on my unit circle, but I have some other things that I do know. For example, sine of 75 degrees, that's equal to the sine of 30 degrees, which I know, plus 45 degrees, which I also know. Totally legal. Let's go ahead and use the sum and difference formulas. And sorry, I kind of blocked it for us. Sum and difference formulas for sine of a plus b is right here. So this is going to be the same thing as sine of 30, which is a, cosine of b, so cosine of 45, plus cosine of a, which is 30, sine of 45. All right, let's go ahead and evaluate this. The sine of 30, once again, same unit circle. We should know our unit circle in degrees and radians. Sine of 30 degrees is right here. Sine of 30 degrees is radical 3 over 2. Cosine of 45, thankfully anything that's 45 or divisible by is always a radical 2 over 2 iteration. So that's going to be radical 2 over 2. Plus cosine of 30. Cosine of 30 is radical, I messed it up, I'm sorry, y'all. Sine of 30 is a half. Sorry, I'm looking at the height here. Sorry, sine of 30 is a half. All right. Cosine of 30 is radical 3 over 2. And sine of 45 is the same thing, radical 2 over 2. So what I get is radical 2 over 4 plus radical 6 over 4. And so what I end up getting here is radical 2 plus radical 6 over 4, which happens to be the same solution as the previous one. No, that's kind of just a coincidence here. Notice how they're cosine and sine values, so it would make sense that they could be similar in this instance. Okay, let's go ahead and move on to our next question. My face is blocking it. Okay. All right, so for our next question, it says find the exact value of sine of u plus v, given that sine of u is equal to 4/5, where u is between 0 and 2 pi, and cosine of v is equal to negative 12/13, where I'm in between pi over 2 and 2 pi. So the first thing that I want to do, I want to apply the sum and difference formula. Well, off to the side, let's go and find some things out. It says that sine of u is 4/5. Let's go ahead and make a triangle for that. So I'm going to go ahead and make a triangle for that. So I know that the hypotenuse is 5 because it's equal to y over r. I know that this whole thing is between 0 and 2 pi, so it's got to be positive. It's got to be in the first quadrant. If this right here, if my y is 4, this is a classic 3, 4, 5, so that's just good to know. Next one, cosine of u is equal to negative 12/13. Well, if I set up a triangle for that, in fact, this triangle is probably going to go the opposite way. I know that x is negative 12 and r is 13. So once again, all of our radiuses, they have to be positive. So negative 12. And it says that it's between 2 pi and pi over 2 and 2 pi, so we can assume that this one right here is going to be our positive 5, classic 12, 13, 5. All right, let's go ahead and use this information to apply the sum and difference formula. So if I said sine of u plus v, so sine of u plus v, if I use the sum and difference formula, that's going to translate to sine of u times cosine of v, and I know u's and v's look similar, so I'm going to go ahead and put a little tail on that, plus cosine of u times sine of v. What we can do is we can actually use these triangles to evaluate what this sum is. And I'm sorry, I should have written, it does. We are finding the exact value here. So what I'm going to do, I'm going to use these triangles to evaluate. So sine of u. Well, the sine of u, let's go ahead and first map out that this is where my angle is here. Sine is equal to, in fact, let me get like a highlighter. Sine is equal to opposite over hypotenuse. So that's going to be 4/5. Cosine is equal to adjacent over hypotenuse. So that's going to be 3/5. Oh, but I'm doing cosine of v. Sorry, I should have chosen u's and v's. Those are very, very hard to distinguish. Sorry. If I'm doing cosine of u over a cosine of u, that's going to be adjacent over hypotenuse. Can't talk this morning. All right, adjacent over hypotenuse. All right, let's keep going. plus cosine of u. Okay, cosine of u. This one is my u graph, by the way. This one's my v graph. All right, so cosine of u is adjacent over hypotenuse. Adjacent, which is 3 over hypotenuse. So that's going to be 3/5. And then sine of v. So sine of v, that's going to be opposite over hypotenuse, which is 5/13. Okay, so what I'm going to get, let's go ahead and simplify this out. I'm going to end up getting negative 48 all over 65 plus 3 times 5, 15 all over 65, and I should get negative 33 all over 65. And so that right there is the exact value using sum and difference formula of sine of u plus sine of v. All right, let's go ahead and practice rewriting. It says use the sum and difference formulas to rewrite the following as a sine or cosine or tangent angle. So we're just going to actually use the sum and difference formula to rewrite it as a single value. So looking at this, let me actually pull up my sum and difference formulas again. Looking at this, it looks like I have cosine of A, cosine of B, minus sine of A, sine of B. So let's see if I can find that. All right, cosine of A, cosine of B, minus sine A, sine B. So I know that it's this sum and difference formula here. So let's rewrite it. This is going to be the cosine of A, which is pi over 7, plus B, which is pi over 5. So all I need to do is use my awesome combining fractions skills to simplify this. So cosine, all right, if I want to add pi over 7 plus pi over 5, I need to get a common denominator. So I'm going to multiply this one by 5 over 5, and I'll multiply this one by 7 over 7. So what I end up getting is the cosine of 5 pi over 35. And then I have plus 7 pi over 35. So what I'm going to end up getting is 12 pi over 35. So this is the same thing as me saying cosine of 12 pi over 35. All right, let's go ahead and try the next one. All right, so for the next one, I want to use the same thing. How can I use sum and difference formulas to rewrite this as basically a single trig function? Well, I have cosine of A times cosine of B minus sine of A times sine of B. This one honestly is the same format, so I'm going to go ahead and use the same format. Sorry, that's such a boring answer there, but let's go ahead and do that. So this is going to be the same thing as cosine of A, which is 130, plus B, which is 40, which is the same thing as me saying the cosine of 170. All right, hopefully this is too easy for us and we need to keep going. All right, just a couple more questions for the day. All right, so applications of sum and difference formula says write cosine of arctangent of 1 plus arc cosine of x as an algebraic expression. Really all I want to do here is I want to just apply the sum and difference formula to rewrite this one. So really I have A, cosine of A plus B. So let's go ahead and use that again. If I have cosine of A plus B, that's going to be the same thing as me saying cosine of the arctangent of 1 times the cosine of, the arc cosine. Hopefully should ring maybe a bell. I forgot to see there. And then we're going to say, minus sine of arctangent of x times the sine of the arc cosine. Sine times the arc cosine, okay? Sine times the arc cosine. Okay. All right, so what I'm seeing here, if we're saying cosine of the arc cosine, and then we're saying, if I think about what is cosine of the arc cosine, I should be thinking about the whole idea of the properties of inverses. So cosine and arc cosine are inverses. So if I take the cosine of the arc cosine, if I take f inscribed with its inverse, f inverse of x. The property of inverses is that if I put a composite function together just containing the original function and its inverse, it always equals 1. And so this actually cancels to 1. So really what I'm left with here is just cosine of the arctangent of 1 minus sine of the arctangent of x times sine of the arc cosine of x. All right, so really what I want to do is I want to go ahead and create a triangle for each of these. So I want to go ahead and create a triangle for each of these. If I have arctangent of 1, I'm going to go ahead and create a triangle for that. So a lot of this unit is going to be about making that triangle. Remember that tangent is equal to opposite over adjacent. It's that TOA part. So if I have tangent of 1, or even arctangent of 1, that's the same thing as me saying, okay, 1 over 1, I get an output of 1 over 1, which is y over x. So arctangent of 1 is the same thing as this whole thing equaling 1, because we're thinking about inverses. I want to create a triangle for that. So tangent is equal to opposite over hypotenuse. I'm going to say 1 over 1, because to write 1 as a fraction, you could just put 1 over it. So just using a little bit of Pythagorean identities, this is going to be radical 2 here. And so this will be the triangle for, we'll call it U. Okay, so the cosine of the arctangent of 1, we are going to be able to evaluate that. Let's go ahead and see if we can draw another triangle for the arc cosine of x. Okay, so a triangle for the arc cosine of x. Well, if I write x as x over 1, I know that cosine is equal to adjacent over hypotenuse. So we're saying that the hypotenuse here is 1 and the adjacent is x. Let's go ahead and use Pythagorean identity to find the other piece. So I know that 1 squared is equal to x squared plus, we'll say, question mark squared. And so if I go ahead and solve, for question mark squared, I get 1 minus x squared is equal to question mark squared. And so the square root of 1 minus x squared is question mark. Note that we don't have to take the plus or minus in this instance because we're dealing with a triangle here. All right, so we're going to say square root of 1 minus x squared here. Okay, all right, so now that I have all of these triangles, I'm going to go ahead and evaluate each of these pieces. In fact, I'll kind of do it in a different color here. So the cosine of the arctangent. So basically what I'm saying is, instead of saying arctangent, I'm actually going to replace arctangent with this triangle here because I already made a representation for it. So what is the cosine of the triangle? Well, cosine is equal to adjacent over hypotenuse. And so what I'm going to get is 1 over the square root of 2 times, well, this whole thing right here cancels to just an x, not a 1x, my bad. It's going to cancel to just an x, and so then I'm going to get times x minus, okay, sine of the arctangent of x. So I want to know of, not x, of 1. We wrote that wrong. Sine of the arctangent of 1. So really I'm asking, hey, what's the sine of, in fact, let me highlight this triangle in blue. This is asking, hey, what's the sine of the blue triangle? Well, sine is equal to opposite over hypotenuse. And so that's going to be the same thing as the square root of 1 minus x squared all over 1. And then I want to multiply that by the sine of the arc cosine of x. So I want to multiply that by the sine of the arc cosine of x. Well, the sine of the arc cosine of x, that's the yellow triangle, arc cosine of x right here, is going to be, let's see, the sine of the arc cosine of x is going to be adjacent over hypotenuse, which is 1, once again, all over the square root of 2. So we get 1 over the square root of 2 right there. All right. So if I want to just go ahead and simplify this, it looks like I have a common denominator of radical 2. So what I'm going to end up getting is In the numerator, I'm going to have x minus the square root of 1 minus x squared all over the square root of 2. All right, so for the next video, we're going to go over, actually not even the next video, we'll do this in person. We'll go over more of this problem type, and we'll go over some more of the earlier problem types, hopefully involving tangent also. All right, that's pretty much all that I have for you guys today. I hope you have a good day, and make sure that you sign up to meet with me at some point.